Alright, you are welcome again. Today let's treat complex numbers. Introduction to complex numbers. In one of our previous tutorials, we treated formation of number system. In that tutorial or in that lesson, we talked about how number systems came into existence. You get it? And then in this lesson, we're going to treat complex numbers, how it came about. Okay, now let's go. Let's say, for instance, we want to solve a quadratic equation that looks like this: x squared minus 2x plus 2. Okay, let's just approach this question with quadratic formula, and then we have quadratic formula to be minus b plus and minus square root of b squared minus 4ac all over 2a. And then discover that in this equation we have a equal to 1, b equal to minus 2, and then c equal to 2. All right, hope you get it right. Good. Now, in fixing this in a quadratic formula, we are going to have 2 plus and minus square root of, our b is what? Minus 2. Then the square of it is going to give us 4 minus open bracket. We have 4 times our a is 1 times our c is 2 times 2, close the bracket, all over 2 times a. So we're going to have 2 times 1. So we're going to have 2 plus and minus square root of 4. So in this bracket, when we multiply, we're going to have 4 times 1 times 2, which is equal to 8. So we're going to have square root of 4 minus 8 all over 2. Okay, now let's go. We have 2 plus and minus square root of, when we say 4 minus 8, is going to give us minus 4 all over 2. You get it? Now let's go. We're going to have 2 plus square root of minus 4 all over 2, or 2 minus square root of minus 4 all over 2. Now let's still split this into 2. We're going to have 2 all over 2 plus square root of minus 4 all over 2, or 2 all over 2 minus square root of minus 4 all over 2. Now, when we say 2 divided by 2, is going to give us 1, and then square root of minus 4 all over 2 is the same, or 2 divided by 2 give us 1, minus square root of minus 4 all over 2 is still the same. So in this case, we try to find the square root of minus 4. We discover that, wow, it's not possible. It's not possible. So what are we going to do? So in the law of surd, we can split this square root of minus 4 into 2. And then in doing so, we're going to have something that looks like this. 1 plus, we have square root of 4 times square root of minus 1. You get it? Square root of 4 times square root of minus 1. So when you say square root of 4 times square root of minus 1 on that side, it's going to give you what? Square root of minus 4. Okay? All over 2. Now in the other side, let's still do same. We're going to have 1 minus square root of 4 times square root of minus 1 all over 2. Okay? So let's go. Square root of 4 is equal to what? 2. So we have 2 times square root of minus 1, or 1 minus square root of 2. Square root of 4 is 2 times square root of minus 1 all over 2. So when you perform this operation, we're going to have 1 plus square root of minus 1, because in the above 2 we cancel 2. Okay, so we'll be left with square root of minus 1. We have 1 plus square root of minus 1, or 1 minus square root of minus 1. Hello. So this is where we arrived. And then we asked, what on earth can we say that square root of minus 1 is what on earth? Square root of minus 1. How possible is it? So then we discovered that from here, let's assume or imagine that there is a number that looks like this. Let's imagine that there is a number that looks like this, which is what? Square root of minus 1. So in our imagination, we just say, let's just call it imaginary number. Let's call it what? Imaginary number. We imagine that it exists. So let's go. That means we're going to say that this square root of minus 1 is what? Imaginary number. So from the word imaginary, we pick the first letter, I. And then we call it what? Imaginary number, I. Okay? So we have, that means we're going to have in this equation 1 plus I or 1 minus I. Hello. So the solution to our quadratic equation x squared minus 2x plus 2 is giving us 1 plus I or 1 minus I. And then you discover that this is different from real numbers we have been encountering with. So this is the invention or the introduction of imaginary number to the set of real numbers. You get it? So the introduction of imaginary number to the set of real numbers is called complex number. The introduction of imaginary number to the set of real numbers is called complex number. Or you can simply say that complex number is a set of numbers that contains imaginary number. Hello. So you discover that from this place now you can see that you'll be able to find square root of a negative number. You'll be able to find what? The square root of a negative number. For instance, you can find the square root of minus 9. You can find the square root of minus 16, square root of minus 25, square root of minus 64. All those ones you can find their what? Square root with the help of this imaginary number. Hello. So now we will just say that complex number can be represented by the letter what? Z. So just say let letter Z represent the what? The complex number. And then we'll say that complex number always or usually appear in the form of x plus iy. Hello. We say that complex number Z always or usually appear in the form of x plus iy. So we say that Z is equal to x plus iy. Now you discover that in this expression here, we have x and then we have iy. So we call x the real part. We call x the what? The real part, and then we call iy the imaginary part. Okay? So now remember, whenever you see something like re open bracket z, it's talking about the real part of z, or the real part of the complex number. Re, the real part. Okay? Now, and also when you see im z, it's talking about the imaginary part of the complex number. So we have in the complex number z, x plus iy. So we say that x is the what? The real part, and then iy is the imaginary part. So from here you are to note that the complex number z equal to x plus iy, the real part can be 0. Can be what? 0. So if the real part is 0, that means you have z is equal to what? iy. And then more also, the imaginary part can also be 0. And if the imaginary part is 0, that means you have z is equal to x. Hello, please don't be confused. And then the real part and the imaginary part can be 0. And if this is the case, that means we have a zero complex number, we say that z is equal to what? 0. Hello. What I'm trying to say here is this. The imaginary part can be 0, and then the real part can be what? 0. But also the real part and the imaginary part at the same time, both of them can be 0. So we call this zero complex number. So if the real part is 0, that means we have z is equal to iy. If the imaginary part is 0, that means we have z is equal to what? X. If the real part and the imaginary part are 0, that means we have z is equal to 0. All right. Now let's go. In complex number, we have I minus 1, minus I, and 1. Hello. Now let me show you what I'm trying to say. You know from the beginning that we say let's call square root of minus 1 a letter. Let's call it what? Letter what? Letter I. That means I is equal to square root of minus 1. Okay? Now what of when you have I square? What of when you have what? I square. What are we going to have? So when you have I square, that means we're going to take the square of it. So when you take the square of it, you discover that the square outside will cancel the square root inside. So you discover that I square will give you what? Minus 1. So we say that I is equal to square root of minus 1, and then I square will give you minus 1. Now let me show you more. What of when you have I raised to power 3 or I cube? What are you going to have? So that means you can split this into 2, saying that I raised to power 3 is the same as saying I raised to power 2 times I. Is that true? Yes. And then you know that from the above that I raised to power 2 is minus 1 times I. So minus 1 times I is what? Minus I. So I raised to power 3 is minus I. Hello? Good. You can see from the table here, okay? We have I raised to power 2 to I raised to power 11. And then continuously. You get it? Good. Now, when you have something like I raised to power 4, how is it going to be, or what is it going to look like? How is it going to look like? So we're going to see that I raised to power 4 can be splitted into 2. I raised to power 2 times I raised to power 2. So, and then you remember that I raised to power 2 is what? Minus 1. They will say minus 1 times minus 1. So minus 1 times minus 1 is what? 1. So therefore, I raised to power 4 is equal to 1. Okay? Good. What of in a situation whereby you have I raised to power 5? You can say that I raised to power 5 can be written like this. I raised to power 4 times I. And then you remember that I raised to power 4 is what? 1 times I. So 1 times I is what? I. Okay. More also, when you have I raised to power 6, what is it? I raised to power 6 can be written as I raised to power 4 times I raised to power 2. So I raised to power 4 is what? 1. And then I raised to power 2 is minus 1. So we can say 1 times minus 1. So 1 times minus 1 is minus 1. So therefore, I raised to power 6 is minus 1. Also, when you have I raised to power 7, I raised to power 7 can be written like this. I raised to power 4 times I raised to power 2 times I. You get it? Okay, I raised to power 4 is what? 1. I raised to power 2 is minus 1 times I. So I'm going to have 1 times minus 1 is minus 1. Minus 1 times I is minus I. So therefore, I raised to power 7 is equal to minus I. Okay? Okay, when you have I raised to power 8, what is it going to give you? I raised to power 8 can be splitted into 2 like this. I raised to power 4 times I raised to power 4. So I raised to power 4 is equal to 1 times 1. So 1 times 1 is 1. I raised to power 8 is equal to 1. Remember also, when you have I raised to power 9, it can be written like this. I raised to power 4 times I raised to power 4 times I. So 1 is the same as I raised to power 4, right? Or I raised to power 4 is 1. So we're going to have 1 times 1 times I. So 1 times 1 is 1. 1 times I is what? I. So I raised to power 9 is equal to I. But also, when you have I raised to power 10, it's going to give you I raised to power 4 times I raised to power 4 times I raised to power 2. So I raised to power 4 is what? 1, and then I raised to power 2 is minus 1. So have 1 times 1 times minus 1. It's going to give you minus 1. So I raised to power 10 is equal to minus 1. So when you have I raised to power 11, I raised to power 11 can be written like this: I raised to power 4 times I raised to power 4 times I raised to power 2 times I. Okay, so have I raised to power 4 is equal to 1. I raised to power 2 is equal to minus 1. So have 1 times 1 times minus 1 times I is equal to minus I. Okay, good. All right, I want us to stop here for the introduction to complex number. Please, we have just treated how this complex number came into existence, then how this complex number is being represented by the letter Z, and it has 2 parts: the real part and the imaginary part, and then the countings. All right, please, let's take more examples. Please, if you are watching this video for the first time, please help us and click the subscribe button to subscribe to our channel. All right, thank you very much. See you next time.